In this video, I'm going to cover more Introduction to Programming on Plan 9, and this will be doing some basic 9p stuff. There is a bunch of stuff that is similar to other Unix systems, but 9p is a very Plan 9 specific thing. So I'll go over some basic, a basic virtual file system. This isn't going to be the fine details of the 9 protocol itself, but more about how one would handle it at the surface user program level. I got my new and improved fake FS. I'll have a link to it in the description. To start off, I'll need my u.h and libc. Those are the bare minimum for any sort of 9-front program. I'm also going to need the 9p, fcall, and thread is also required for 9p. The next sort of important thing will be this serve struct here. So this will hold the function pointers for what is ran when each of the 9p messages come in. Here I'm setting my own to handle these particular requests. In this case, I'm going to be handling start, end, and read and write. This fake files is my own thing. There's a function I'll get to next that makes the fake files, and you can feed particulars into that any way you like. Here I'm setting them up so I have a name, a mode, and these will be the function pointers to the particular functions that will be used for reading and writing on those files. So the first thing is going to be fs start. This will be called as soon as the service is started, so I'll do my file creation here. So I'm going to grab the name of the user who launched this. I'm going to allocate a tree here at serve tree, and I'm going to set a owner and a mode. The last argument here, this nil, this is for a function pointer if you want a special way of handling destroying this tree. So next I'm going to get a pointer to the root of that tree. So this is a type file here. And I'll go to that root, and I'm going to create a file called fake, owned by the user. It's going to be the type directory with that mode. Again, the nil here is for a function pointer. In this case, this is if you want to put some particular piece of data you want following this file around. In this case, it's none. If it fails to create it, it'll fail out of the program right here. So, but it will return a pointer to another file, the fake file directory. So next I create the actual files in that directory. That's called fake. So I'll loop through the fake files I already set up before, setting the user and the mode and the name of the files. And in the end, that little, this is called aux, I'm going to set a pointer to that particular entry in fake files. I'll need that later because that has the function pointers that I'm going to be using to read and write those particular files. So that's going to actually finish up sort of making the directories. Next, I'm going to have like a log file, and this is going to be setting that up. So I'll get the, since I already have the username here, I'm going to set up a path to their home directory with a particular name of the fake log. I'm going to see if they already have it, access writable. If not, they'll create one. If it's there, it'll just open it. Both will return the file descriptor. And then actually post to the log, saying that it started at a certain time. And then the last thing is some, going to malloc some buffers I need for some of the other programs or some of the other files. This emalloc 9p is just a wrapper for malloc. It'll do a malloc, check to see if it worked. If it doesn't, it'll run sysfatal and just bail out the program right here. So my old Unix teacher gave me the advice to never start a process you don't know how to stop. So my next function here is the end function. So neither start or end functions cover actual 9 protocol messages. These are just for the program handling the messages. So I'm going to be posting to the log that the service shut down. I'll free those buffers. and then make sure everything just sort of exits cleanly. So for the actual 9 protocol part here, so most of the stuff, the defaults will be fine for what I'm doing. I'm going to go ahead and use the libraries auth, attach, walk, open, flush, and those sort of things. But I do need to handle reads and writes myself. So first off is my read function. This brings in a request. Let's see here. Bring this up. It should be in here. Yeah. Here's what comes in a request. So you're going to have the F calls, and that's going to be the actual sort of the raw 9p data. So here's what it looks like here. So, you know, for things like reads and writes, you'll have an offset, a count, and the data coming in. You know, stuff for your authorization, all that. That's in the F call in the request. So another thing is the FID. This is going to have sort of the actual file data. In there will be the QID, and that's like the unique, you know, the unique ID for the file. So the actual unique ID is like 64 bits. So you can go nuts making all the files you want. It will come with an auth or an aux. That's for stashing your own stuff. So in the read here, I'm going to be setting that outputting fcall, the count, to 0. So I'm doing this right here. This is for catching errors. It's to make sure that later code was updating this when it was generating output. Here I'll go ahead and grab that pointer I stashed in aux earlier to the fake file. And now all requests need to be responded to, and for that there is the respond function. So respond's going to take a request, and the second argument is actually a character pointer if you're going to return an error. So in this case, I'm going to feed the fake read pointer, function pointer from that entry in fake files. I'll give it also the request, and it will return back a character pointer if there is an error. If you put nil here, that means no error, and that means everything worked fine. So write works basically the same way, except I don't need to check, you know, for the do anything with the count right here. But yeah, it just sort of grabs the fake file information out of that pointer there, and then responds with this, which will actually kick off whatever that particular file is supposed to do, and respond back with an error or not if it's done. So next I have my usage in main. Main's only going to take 2 arguments, the serve name and mount point. The defaults are fakefs and /n. It'll print out those values to standard error when you kick it off, so you know. Right there. It's also going to check to see if you're running webfs, because I have a file later that will use that. And this post mount serve, this actually kicks off the process that will service the requests. It's automatically going to mount it and post a descriptor in /serve. If you want, there's also a threaded version of this function, but for now I'll be sticking with the single thread. So now the read and write functions of the individual files. So first off is my old-timey time file. So this will just get the, a little bigger there. This will just get the time of, which is the Unix epoch, or the number of seconds since like 1970. It packages that in a fun message, and then it will do this read string. This comes with 9p. This takes the request, whatever buffer you send. It's expecting that it's going to get a string of text. So in there, it will be running like strlen to get the string length, and feed that into the OF call count, and put your text in the OF call data, and you know, handle all that stuff behind the scenes for you. And that'll actually be your outputted data. Since I don't have an error, I'm just returning nil. So next is my backtalk file. This is going to get the name of the user reading the file, and it's going to put that in a nice little sassy message. Next is my iChing file. This uses a little random number generator that comes with libc to produce iChing hexagrams. Again, it's going to just do read string as a response, and since I don't really have any error conditions, I'm just going to go ahead and return nil. So finally, we're getting to some write stuff here. This is for the rot13 file. This does the classic rot13 Caesar cipher. So it's going to, for writes, the count it responds back with is the number of bytes written into it. This is just to make sure it doesn't error. I'll just tell it that all the bytes that came in were actually written. You know, you can add up the value of the bytes actually written by whatever your process you're running and send those back. Whatever you do, it might be best to know, like, if there was a short write or something. But in my case, I'm just going to say everything worked. But in reality, I don't want to overflow, so I'm actually going to check it against the size of my buffer I have and only write it that -1, so I have one null byte at the end because this is a string, and that's how the system will know that you're at the end of a string. I'll then move the incoming data. Well, first I'll clear the buffer, and then move the incoming data from the 9p request into my buffer of so many bytes. And then I run through the actual encryption thing. So I'll read it into the buffer, then encrypt what's in the buffer, and then return nil. When it comes to reading that file, since it's already been encrypted, all I got to do is just read back the buffer as a string of text. The next one was a request from a viewer. They asked if it was possible to know if a file had been accessed other than like polling the access time metadata. I didn't know of one off the top of my head, but I knew that it was possible to handle that in a file system. So I made a file called Honeypot. In it, there are going to be some juicy corporate secrets. However, every time it is read, it will write out to a log file. So I'm going to print time and the user and what they did and put that into the log file that I set up earlier. It'll then return our nil, so there'll be no error message. The right end of it will tell the incoming request that any data was just written. It'll do the log again, but this time it's actually going to respond with an error message. So you may say, that's fine, but then aren't you just like polling a log file? And to that I say that in Plan 9, everything is a file, or at least can be. In this case, I'm writing the text to a file descriptor, and on the other end of it is a file on a hard drive. But the file descriptor could be a pipe to another programming or another program that's, you know, waiting for input. So the other day I did a video showing hardware interrupt messages being read from the kprint device into a file that prints it out on an LCD display. So in that case, I was showing when ports are being activated on an Ethernet switch. So you can totally send data that way. You can also look into the note passing system that's in there. So that's a way of sending data to and from other programs that are running. And finally, I have one that actually interacts with another virtual file system. So this one here, RSAT, this will use WebFS to fetch a JPEG from a website. So in this case, it's going to go get me a weather satellite image from NOAA.gov. So first I'm going to check to make sure that I can actually access WebFS. If you can't, it'll return back that it's not there. It's going to open clone up, and it's going to read a value from it. And that will give you a number that corresponds to the name of a fresh directory. So I'll then double check that there's a control file in that particular directory, and then write the command to fetch the JPEG I want. So it's going to do this sat URL, which this is how the WebFS wants it formatted. So it's URL space and then the URL that you want to grab. So it'll do that. Next, I check to see if the last data that was pulled in is new enough. Doing testing, I found that some programs do lots of successive reads. So rather than call the website on every read, I check to see if the old image is current enough. I probably need something to make sure I don't get caught jumping into a fresh download mid-read, but for now this works. So I have a timestamp that I set. And if it's new enough, I just read the buffer of whatever the last length was and go ahead and print to the log that I'm getting old data and return with no error message. So if I do get fresh data, I'm going to go ahead and set my previous buffer to 0. So the data is going to be called from a file called body in that clone directory that I got. So I'm going to get generate a path to that, open that file up, and again doing various testing, I found it was best to do lots of little successive small reads. The standard read in plan 9 will block until it gets some data. So if you get out of sync, reading from a file that's also reading, you can get lots of kind of hang-ups. So doing little small ones like that seem to avoid that. So that's what I went with. I'll get a timestamp for my fresh data and set whatever the length was to it and print to the log that I got some fresh data. When I read it back, I'm not going to do read string. I'm going to do read buff. I do this because the read string one uses strlen to get length. That can cause issues if there's a null byte anywhere in the data. So yeah, if you're doing like binary stuff, use read buff. Then I close all the files that I was involved with in WebFS and return with no error. All right, and now I'll give a little demonstration of the file system I made here. Let's see, it's fakefs version 2. Run fakefs. So return back the serve and the mount point. So if I look in end fake, I got my files there. Let's see, I can try my old-timey time message. And it comes back with my little thing here. Try backtalk. So that's my username here. And let's get my fortune here. And there's my little I-Ching hexagram all printed out. The next we'll do the rot13. So it'd be easier if I just change directory there to fake. All right. So in lib, there's the rules of acquisition from Star Trek. So if I cat that, lib, I have that. I can cat that, lib, ROA, into the rot13 file. And then if I read that back, it's now all encrypted. So that works. Next we'll do the honeypot one. So this is my home directory. It went ahead and made a fake log. So I can read it so far, and all it does is have the little start message in it. So if I go and read the honeypot, I get my juicy corporate secrets. And over here, it shows that the read requests came in. So at this time, this user read it. If I put something in there, into honeypot, I get back my error message. So that's my write error. The authorities have been notified. And over here, it will record that at this date and time, this user tried to write to the honeypot. So, oops. And finally, we'll try the satellite. So that's going to be a JPEG that comes in. I'm going to use page on sat.jpg. That's going to fire that up, and there's my satellite image. And I should actually see that information about it in the fake log there. So yep, it came in saying it read the image down at a certain size, and then continued processing it with the old data that was already in the buffer. So hopefully that was interesting. You can see some fun stuff you can do with the file system. You can even make virtual JPEGs that are actually pulling stuff down from other places. You know, make files that take in data and process it and spit it back out, whatever you want. So yeah, I'll have links down to the man pages and this particular fake FS in the description, so you can read up on all the various stuff involved in that. And as always, have fun.